Okay, good evening. Hi, welcome all for evening session. And very few has entered for this session. So hope many others will join later. And we'll just have a few minutes. We'll just go for waiting for few seconds. So in the previous session, under physics concepts, we discussed on electricity, where we learnt about heating effects of electric current. What are the applications of heating effect of electric current we learned in previous session. In this session, we are going to learn the magnetic effects of electric current. I'm going to complete, if not Monday. So today we'll be having a lot of discussion on magnetic effects, but the topic is so subjective. It is not entertaining, it is very subjective. The concepts are very subjective, so you want to concentrate very keenly so that you can understand the concepts. Still the participants are so less. Nandita, Tejashwani, Kirti, Priyanka, Sneha, okay, these were existing right now. I don't know how far the people will join, so we'll start the session. Okay, shall we start the session? My audio is clear for everyone. Shall I start? Okay, we'll start the session. Now I'm going to share the screen. If anybody have the problem with the audio, later on you can go through the same video to fill up the gap. So few will have the network problem and few will have very clear. So Priyanka told that is very clear and everything is audible clearly. Okay, now I'll start the session. Now, what are the magnetic effects of electric current? Is there any relationship between magnetic effects and electric current? If it is there, how they are related? Now, we are going to discuss one by one about the magnetic effects of electric current in this session. Now, I'll share on discuss in this session field and by using magnetic induction and magnet and are made. They can observe at the laser and motors. Under this, what is the importance of fuse? Safety measures definitely asked in your exam. I highlighted what we are going to discuss under this session. These were the subtitles we are going to discuss today and another one more session, so that will complete on magnetic effects. Okay, voice is not audible. What is the problem? Have you all seen the mind map? Have you all seen the mind map? So, as the mind map, we are going to discuss what is magnetic field, what are magnetic lines, and the current passing through a straight conductor or in a loop conductor, and what is the difference between that, Fleming's right hand rule, Fleming's left hand rule, and solenoid, what is solenoid, and how the solenoid is used in making electromagnets, and electric motor, electric generator, and finally domestic electric circuits, where we are going to learn what is short circuit, what is fuse, and what are the measures of the fuse and earthing. These concepts we are going to discuss under magnetic effects. Hope now everybody cleared with the mind map. Yeah, good evening, Revati. Now, okay, when I share the screen, definitely that is the problem. There will be break here and there. Okay, what about now? All of you cleared with the mind map? I discussed again on the mind map. All of you cleared what we are going to discuss in this session? Okay, sometimes breaking. Okay, it will be. Okay, obviously Priyanka, when I share the screen and you all observed, right? When I have a live chat, definitely there won't be any problem. When I share the screen at the so when I share the screen, you just asked very frequently in your board exam, either in a form of diagram or preventive measures or the properties, on the properties. Anyhow, 2 marks, 3 marks question will be arised from this chat. Okay. Okay. In order to solve the problem, only one option left over is for every, and I'll revise it once again. If you miss something there, you recollect here. Okay? Shall I? Hope network is so slow because I'm not getting reply immediately. The screen and I'll come back here. There may be problem in my audio. Okay. Where we study this, we are going to discuss now. A deep look on the image. Now, under the concept electricity, you all learnt how to draw circuit, right? While drawing the circuit, what you are going to apply? You are going to connect with the battery and a conductor, right? Then ammeter, resistor, key, switch, right? All this will be connected in the chapter electricity, that is called as circuit, right? In the same way here, there is a circuit here where there is a conductor. Where is conductor? Now look at X and Y. Look at X and Y. This is a conductor which carries electric current. Now how is the conductor? It is a straight line, right? Now in this we are going to discuss whether the compass X and Y, when it parallel to the XY. Okay, now it's clear. Parallel. Okay, XY is not given, but you can see it in your material, right? So XY is a long straight conductor where we kept the compass parallel to the XY. Now, current is allowed to pass through the conductor, straight conductor. Now you can see the compass will show depletion. The compass needle will be depleted at right side. At right side. Remember, when the current is allowed to pass, it shows depletion. Either it is at the right side or left side. When we reverse it, then the depletion will be opposite side. Okay. Okay. So much problem. Okay. I'll repeat the concept. Now you all gone through the image where there is a diagram of circuit. In that circuit, there will be XY, which is a straight conductor. When electricity is passed, current is passed through the conductor, the compass needle show depletion. Why it show depletion? Compass is related to the magnetism, magnetic field, right? We just passed electric current, but we are finding depletion in the compass. This indicates that where there is a current, there will be magnetic effect. Where there is a current, there will be magnetic effect. The depletion of the compass says that there is a relationship between electric current and the magnetic field. Now at least any clarification? Okay, now do you have audio problem? Now do you all not hearing my voice? Okay, Arpita, I'll repeat the concept. Now let me know, at least now, can you all hear me? Any audio problem? Now too? Now it is audible. Okay, Priyanka also. Okay, I'll repeat the concept. You just have the material in front of you. Okay. Now look at the image in your material. Now, what is given in the material? The diagram X and Y. X and Y is a long straight conductor. Now in the same way as we connected in electricity the circuit, in the same way even here the conductor, resistor, battery, ammeter, switch were connected in a circuit. And now one difference is we'll keep a compass parallel to the XY. One additional thing is a compass is kept parallel to the XY. Now, when current is passed through the circuit, the conductor carries the current. This we know. Conductor always carries the electric current. Right? In the same way here also the conductor carries the current. But the compass which is kept close to the XY, parallel to the XY, it shows depletion, movement. It shows the movement. When the compass will show the movement? When there is a magnetic field. Right? When there is a magnetic effect. When there is a magnetic force. Only then the compass needle will be depleted. Right? So the deflection of the needle shows that when the current is allowed to pass, it results in magnetic field. Current also have magnetical force, magnetical field. Okay, this is so simple. Along with the current, there is a current field. In a higher order, you think it's simple. In an electric circuit, when the current is allowed to pass through the conductor, the compass needle will show deflection. When the compass needle show deflection, that indicates there is a magnetic field. What is the conclusion? When there is a current, there will be magnetic field also. There will be magnetic force also. They are interconnected. Should I repeat once again? Okay, Kirti is very clear with the concept. It's simple. Don't get confused. When there is the current, both. The conductor will have the current passing through the conductor. Meanwhile, it creates a magnetic field. Okay, Nandita is having so much of problem. She can't hear not even single word. Okay, Revati is also cleared. Okay, Nandita, you have network problem because others, they were cleared with the concept. And they have only one problem. When I share the screen, they can't hear me. But Nandita is having a continuous problem. So Nandita, please sit in the problem. Okay, let me hope it will be rectified. Now, I'm going to share the screen. You just have a look on the image. So this is the, and deflection is, it is having magnetic field. There it has created magnetic field. Now what is this magnetic field? Which shows certain properties. The like poles repel, unlike poles attract each other. So these are the basic concepts everybody. Now look at the magnet. The magnet, like poles repel each other. When north and north bring closer, they repel. When south and south bring closer, it repel. When north and south of two magnets bring closer, they attract. When a bar magnet is suspended freely, always it comes to the direction north and south direction. So, what is any sense that attracts? These are very important. Okay, till now we discussed what is magnet and what are the properties of magnet. What is magnet? Any substance which attracts iron fillings towards it is known as magnet. What are the properties of magnets? Every bar magnet has north and south poles. Like poles repel, unlike poles attract each other. When you spray the iron fillings towards the bar magnet, it attracts the iron fillings in a particular pattern. And when you suspend a magnet, always it comes to the north and south direction. These are the properties. Now, okay, if it is cleared, I'll move on. Oh, very good, Manasa. First time. Good reply. She understood the concept. Very good, Mansa. And very good cartoon, right? Okay, now again I'll share the screen and I'll come back here. What is magnetic field? The region surrounding a magnet in which the force of the magnet can be detected is known as magnetic field. I'll repeat. Now, suppose there is a bar magnet. The region surrounding a bar magnet in which the force of the magnet, there should be some force, and that force can be detected. And that detected force is called a magnetic field. Shall I repeat once again? The region surrounding a magnet in which the force of the magnet can be detected is said to be magnetic field. And what is the unit of magnetic? The SI unit of magnetic field is magnitude and direction. The magnetic field is a quantity that has both direction and magnitude. And how to identify magnetic field? With the help of magnetic compass. Previously we saw one diagram where there was a compass. By using that compass we can identify the magnetic field. And what are the characteristics of magnetic lines? The lines which are represented in the magnetic field are called as magnetic lines. The magnetic field lines are existing around the bar magnet. The magnetic lines emerge from the North Pole, merge at the South Pole. And always the direction of magnetic field lines is from South Pole to the North Pole. All the magnetic lines are okay. Hope everybody understood the concept. What is magnetic field? The region surrounding a magnet in which the force of the magnet can be detected or magnetic force is experienced is known as magnetic field. In the magnetic field around the bar magnet, there will be a pattern of lines called magnetic lines. And how these lines are drawn? The lines always emerge from the North Pole, merge at the South Pole. And the direction is always from the South Pole to the North Pole. And the lines are closed curves. And the lines never intersect each other. These are the important properties of magnetic lines. Okay, all of you clear with why? Any problem? I'm not getting any reply. What about magnetic field and magnetic lines? The concept is cleared? Okay, Priyanka, now voice. Did you find any break in voice? Okay, Manasa, very nice. Good. Okay, Kirti is saying that's clear, but Revati is having network problem. Okay, Priyanka also having the problem. Okay, you had the problem when I shared the screen, right? Only you're finding the problem when I shared the screen, right? By the help of diagram. Now I'll share the image. You just observe it and apply what we discussed till now. You apply to the diagram. Okay? Okay, look at the image. There is a bar magnet and magnetic lines around the bar magnet. What I told the properties, always the magnetic lines emerge from the North Pole. You look at the arrow from the North Pole. The arrows are arising from the North Pole, right? You look at the arrows from the North Pole, and then they move in a concentric circle and then merges at the South Pole. Merges at the South Pole. The direction at the center, magnetic lines is from the South Pole to the North Pole. Remember, the magnetic lines at the center is always from the South Pole to the North Pole, but the lines emerges out from the North Pole, merges at the South Pole. And that is, the lines are closed. You look at the left side, top side and the bottom side, all the lines are closed. But at the center it is not closed. Always it will move in a straight line in the center. Okay. But rest of the lines are closed. And if you see the diagram, there is no intersection. No intersection, no crossing of each other. No intersection, they never cross each other. Okay. So this is about the properties. These are the properties of magnetic lines. Okay, all of you gone through the diagram, right? What does diagram says? Always at the center the lines will be straight, that is passing from South Pole to the North Pole. But the lines will emerge at the North Pole, merges at the South Pole. Always the lines emerges from the North Pole, merges at the South Pole. And at the top side and at the lower side, we found concentric circles, right? And not even a single line intersect each other. All lines are separate. There is no crossing over between the lines. All lines are separate and almost all lines are closed curves. They are closed curves. Only at the center, the lines will moving very straight. Okay, cleared with the field lines around the bar magnet? All of you cleared? Magnetic lines and how the magnetic lines are existing around the bar magnet. What are the properties of magnetic lines? This is very important. What is magnetic field? The region surrounding the magnet and the magnetic force is experienced is known as magnetic field. The lines found in magnetic field are called magnetic lines. Magnetic lines emerge from the North Pole, merge at the South Pole. The direction of the magnetic lines is always from South Pole to the North Pole. The magnetic field lines shows closed curves and they never cross each other. No intersection of the lines. Okay, the diagram shows very clear with the explanation, right? So the diagram is as per the explanation. If you see the diagram, almost the points will be cleared. Okay, now I am going to show another diagram, and now you are going to see how the deflection of the compass takes place based on the direction of the current. Remember, when I share the screen, you want to see the direction of the current either from plus side or minus side. Okay, clear? And direction of the needle. Okay, these two concepts, the direction of the current, direction of the needle, you want to concentrate very well. Okay? Now look at the diagram. First diagram. The current is from the positive terminal towards the negative terminal. Okay, clear? At the time, how the compass needle shows the depletion towards the right side. Now reverse the flow of the current. Now reverse the flow of the current, and the compass needle will show the opposite side. When you change the direction, opposite direction of the current, the needle deflection will also changes. Clear with the diagram? Now the flow of the current is from the left side. You just observe the diagram at the left. The direction of the current is left side. So the depletion is towards right side. Now if you come towards the right side diagram, the current is flowing from the right direction, right side, and the depletion is towards the left. Okay. Now what does this diagram explains? It explains a simple electric circuit where the magnetic compass is kept parallel to the conductor. The deflection of the needle becomes opposite when the direction of the current is reversed. Okay. Right? Even it is there in your material. When you saw the left side image, the electric current is towards the right side and the depletion is towards the right. And when you reverse it towards the left, and even depletion is towards the left, what does this indicate? The depletion of the needle becomes opposite when the direction of the current is reversed. Now this is very simple. When the flow of the current, when you reverse it, then the compass deflection is also reversed. That's why it is so. Okay, Triveni now got problem. Not understanding because audio problem. Okay. What about rest of the students? Now what about rest? All of you understood? Should we repeat? Should I repeat this? Now you all gone through two diagrams where the current is reversed in a conductor. Definitely the deflection in the needle will also reverse. Once the depletion shows towards right, at the other time when it is reversed, it shows towards the left. That's all. That's all. Priyanka is having the audio problem. Now Aishwarya has entered. So late, Aishwarya. Okay, cleared with the concept? All of you cleared with the concept? Those who has entered late, you can watch the video again from the beginning. Okay, now we are going to see what happens when magnetic field due to the current through a straight conductor. Now, in the first image, we just kept a compass connected to an electric circuit, and when we pass the current, the compass shows deflection. That means electric current shows magnetic field, magnetic force, right? First image, you just recall first image. Very nice, Revati. Thumbs up. Good. Okay. Have you all recalled the first image? Okay, recall the first image. Electric circuit is a conductor X and Y. There will be a magnetic parallel to the XY. And when current is allowed to pass through the conductor, what happens to the magnetic needle? What happens to the magnetic needle? When we keep a magnetic compass parallel to the electric conductor, when the electricity is allowed to pass, what happens to the compass? Any changes in the compass? I need the reply. Any changes? I already told the first thing, first image. Recall first. What happens to the compass? When it is passed to the conductor, what happens? What do you find in the compass? Yes, it will deflect. Deflect in the sense moves. Right, Priyanka? Where the magnetic field is created where there is a current in a conductor. Now the conductor is a straight conductor. Now a cardboard is connected even along with the compass. One more additional thing, compass is kept parallel to the conductor, and one cardboard is connected, and on the cardboard a fine iron fillings were sprayed. Fine iron fillings were sprayed, and the battery is connected, and current is allowed to pass through the conductor. No connectivity with the answer. And so there is a circuit. X and Y is, the brown line is called as X and Y. X and Y is a conductor, and yellow spherical structure, that is magnetic compass, kept parallel to the conductor, and the cardboard, a square shaped cardboard is connected to the conductor where are iron fillings. How the iron fillings are arranged? When there is a straight conductor, observe the iron fillings, how they were arranged in a concentric circles. They were arranged in a concentric circle. Now this is the experiment to show the magnetic field is created when there is a current through the conductor and compass shows deflection, and when the iron fillings is sprayed on the cardboard around the conductor, the iron fillings will arranged in concentric circles. Always it is arranged in concentric circles. Now you all go through the diagram. There is a conductor and there is a cardboard and iron fillings sprayed on the cardboard. Now when the current is okay, Vidya, Nandita. When iron fillings is sprayed on the cardboard, how the iron fillings are arranged? How the iron fillings are arranged? This is very important. Let me know. Concentric circle will be arranged in concentric. Very good answers. Very good answer. And others, I hope there is more network problem. Other than Priyanka and Revati Revati. Okay, now I'll move on to the next concept. So I told the magnetic field have the quantities like magnitude and direction. Now let me tell, when the current is increased, the deflection is also increases. What does this indicate? The magnitude of the magnetic field produced at a point will increases. Then what is this magnitude? Directly saying the speed will be increased. When the current is increased, the deflection is also increased. The magnitude of the magnetic field point will also increases. Altogether, when current increases, the speed of the movement is also increased. Okay, this is one of the property you should keep in your mind. Okay, let me move on to the right hand thumb rule. The next concept is right hand thumb rule. What does this right hand thumb rule indicates? Now I told where there is a current, there will be magnetic field. And how this current and magnetic field together will have a journey. Now I'll show the image. You just have a clear information how the current. Now you just hold your fingers closed and the thumb rising up. Okay, The thumb pointing up is the flow of the current. Always the current flows in a straight line. Okay. And how the magnetic field will be created? Now, how the fingers are folded around the straight line, that indicates the magnetic field. Now, in total, the thumb points towards the direction of the current. The fingers wrap around the conductor, shows magnetic lines or magnetic lines of the magnetic field. This concept is known as right hand thumb rule. Right hand thumb rule. Based on the right hand thumb rule, we'll have one experiment. Towards the direction of the current, and the fingers wrapped around the conductor shows the magnetic lines of the magnetic field. Right hand thumb rule. Right hand thumb rule. What does right hand thumb rule says? Right hand is the direction of the current, and the fingers wrap around the conductor shows magnetic lines of the magnetic. The thumb, the field lines of the magnetic field. Magnetic field lines are the fingers. Thumb is the direction of the current. This is known as right hand thumb rule. And there will be experiment to prove this. That previously we saw when the current is passed through a straight conductor on the cardboard, when we spray the iron fillings, all will be arranged in a concentric circle in the previous experiment. Now, we'll take a circular loop. We'll take a circular loop and current is allowed to pass through it. Now, how the magnetic lines are formed in the loop, this we are going to study. And that experiment clearly says right hand thumb rule. Okay. Shall we move on? Okay, Kirti is saying that we can move. What about others? But when I repeat the concept, you just cope up with that. Okay. Now, we'll go with an experiment, that is current through a circular loop. Now, this is the image showing on right hand thumb rule. What happens here? You can see the circular loop where at the end and south end points we find a circular concentric circles. Magnetic lines are arising in a concentric circles. As and when we move towards the center, the concentric circles is at the center. It is almost straight line. The magnetic field appearing straight lines at the center of the loop, but showing concentric circles at the ends, top end and at the bottom end. What this indicates, the top and the bottom ends will act as a towards the center. The circular loop are not joining, they are not enclosed, moving far away. But when we move towards the center, it is almost a straight line. This will be well understood with another diagram. Look at this diagram, circular loop. At the ends, north and south ends, it will be in a concentric circles. And rest of the things at the center, it will be straight. Look at this image. Circular loop. At the north and south endings, it is showing circular concentric circles. When it comes to the center, it will become straight. And between the center and the ends, lines move far away. Not a complete concentric circle, it's move away. Okay, all of you cleared with the concept circular loop? What happens in the circular loop? In a straight line, it forms circles. But when we go towards the circular loop, at the ends, north and south ends, it forms a concentric circles, and rest at the center, it will be straight. And between the center and the ends, the concentric circles won't be complete. They move away. The concentric circles move. Now how the right hand rule can be applied here? Now look at the ends and look at the conductor. Conductor indicating thumb. Okay, where the current is flowing in a straight line. Thumb. And how the fingers are around the conductor, the concentric circles are nothing but the wrapped fingers, where at the end you can apply right hand thumb rule. Always the current is in a upward direction in straight line, and the magnetic field is around the conductor. Magnetic field is created around the conductor in a concentric form. This is about right hand thumb rule. Shubha, so late Shubha. We are almost completing this session. Okay, now all of you cleared with circular loop. Anything to be clarified here? Now, which rule will be applied when the magnetic field is due to the current in a circular loop? What rule is applied here? I'm waiting for your reply. This is very important. The rule applied in a circular loop will be asked in your board exam. Waiting for your reply. Yes, Revati, correct answer. What about thumb, Kirti? Right hand rule. Right hand thumb rule. Nandita, very Arpita always answers in a different way and very funny way. Very nice, Arpita. So nice. Arpita is having more creative knowledge. Okay, shall we move on to the... There will be a cylinder like round which An insulated copper wire is wrapped closely, and this solenoid cylinder will act as one end as a north pole, another end as a south pole, and always the coil, insulated coil around the cylinder will show the direction of the magnetic field, and in the center of the solenoid, magnetic field will be in a straight and always uniform. The magnetic lines inside the solenoid is always parallel, straight line and uniform. I repeat, the magnetic lines inside the solenoid always will be parallel, straight lines and uniform. Okay, and when this is connected to the battery, when electricity current is allowed to pass, what happens? Yes, the compass shows deflection, because where there is a current there will be magnetic field, right? But what I told, in the center of the solenoid, the magnetic lines are always parallel, straight lines and uniform. Okay, what happens? Let me see through the image. So, what happens in the solenoid? Now, the coil is wrapped around the cylinder. And the cylinder center is kept hollow, and it is connected to the battery. When current is allowed to pass through the battery, what happens? You just look at the image. In the center of the solenoid, the magnetic lines are straight, parallel and uniform. From the south pole to the north pole, the magnetic strength is uniform. Okay, and at the top side and the bottom side you can see concentric circle, magnetic field. At the bottom they form a concentric circle, but at the center of the solenoid the lines are parallel and uniform. And this principle is applied for making electromagnets. Okay, at the center I told it is hollow. Just take a soft iron rod, place it in the center of the solenoid inside the coil and pass the current. When the current is passed along the insulated copper wire, in the center this magnetic field created around the solenoid makes the soft iron into magnet. Now soft iron will convert into magnet. How the soft iron is converted into magnet? With the help of current, right? Hence, the magnet formed is called electromagnet. Okay, look at this diagram. Battery is connected to the solenoid and the finger is the place where we can keep the soft iron. And after keeping the soft iron and current is passed, what happens to the soft iron? Now the electromagnets are made with the help of solenoids. Okay, you all gone through the solenoid structure. An insulated copper wire is coiled around the cylinder and connected to the battery. And at the center, the magnetic lines will be straight and parallel and uniform. Around the solenoid, it will be concentric circles. Magnetic field will be concentric. When a soft iron piece is kept inside the solenoid and current is allowed to pass, what happens to the soft iron? What happens? I'm waiting for your reply. Yes, Priyanka, correct. It will correctly made. Kirti, it is magnetic. Magnets are made. Very good answers. Very good answers. Now, today homework, you just know about what are the uses of electromagnets. Okay. Okay. Now, questioning session. We discuss questions. Not electron magnet. It is electromagnet. Tejashwini, electromagnet. Okay, my first question. When the current is passed in an electric circuit where the conductor is in a straight line, what does the compass shows? When the compass is kept parallel to the straight conductor, what does the compass shows? Waiting for your reply. What does the compass show when it is connected in a circuit? Okay, no problem, Tejashwini. Okay, rectified the answer. Good. Yes, compass. Very good, Priya. Compass shows deflection. Very good. Okay, very good, very good. Yes, Kirti, Revati, very good answers. Okay, my next question is, yeah, Tejashwini, correct answer. My next question, when like poles of the bar magnets are brought together, what happens? When like poles of the bar magnets brought together, what happens? Repels. Very good. Like poles, repels. What happens to the unlike poles? When like poles repels, what happens to the unlike poles? Yeah, Nanditya, for repels. Yeah, Tejashwini, correct. Yes, Priyanka answered for second one. Unlike poles attract each other. Unlike poles attract each other. Very good. Okay, Arpita, I posed two questions. And your answer is for what? For first one, it repels. Poles repels for first one. And poles attracts for the second one. Okay? Cleared? All of you cleared? Okay, my next question is, when the bar magnet is kept on a paper, just spray the iron fillings around the bar magnet. Do the iron fillings lie haphazard or they attain any pattern? I repeat the question. Keep a bar magnet on a paper, spray the iron fillings. What happens to the iron fillings? They lie same or they attain any pattern? Do they attain any pattern? And what is the name of that pattern? I'm waiting for your reply. Yes, very good, Priyanka. Concentric circle pattern is formed. Very good. Very good. Very good. Good. Very good responses. I thought this concept is so difficult to imbibe in your mind. I thought, but it's not like that. Everybody answering correctly. Very good. Even the toughest concepts, which is so subjective, and even that concepts are very well answered. Very nice of you all. What is magnetic field? The magnetic field is the region surrounded a magnet where the magnetic force is experienced. As a result, it forms the lines. What are the lines called as? In the formation of what are called as? Fly. Come on, hurry up. Yes, Priyanka. Very good. Yes, Priyanka. Field lines are magnetic lines. Both are good. Good responses. Tejashwini, very good. Tejashwini. Yes, all of you answered correctly. Now, the questions on magnetic lines. Okay. Where do magnetic lines emerge? I repeat, where do magnetic lines emerge? Where do magnetic lines emerge? Where do magnetic lines emerge? Emerge. Yes, very good, Priyanka. It is North Pole. Very good. It is North Pole. Always the magnetic lines emerge from the North Pole. Remember, this is very important for your board exam. Remember always. Yes, Revati. Nandita, very good answers. Yeah, Kirti, Arpita, good. Tejashwini, good answer. Manasa, good. Shubha, so nice, Shubha. Very good answer. North Pole. Very good. Shubha, keep it up. Okay, my next question is, where do magnetic lines merge? Where do magnetic lines merge? Where do magnetic lines merge? Yes, Priyanka said correctly. It is South Pole. Yes, Revati, Kirti, very good answers. It is at South Pole. They merge at South. Emerge at North Pole, merge at South Pole. Okay? Okay. Now, question is, at the center, how the lines are passed? At the center, I'm asking about the center. What happens at the center? Shubha, very good. Yeah, it is parallel lines. I need a very specific answer. Direction at the center. Of course, it is parallel lines, Priyanka. I need very specific answer for this. No, Revati, it's not curved. Wrong, Revati. At the center, it is parallel or straight. Yes, Nandita, correct answer. Revati, no. I'm asking at the center. So please practice the diagram so that the concept will be fixed in your mind. At the What is this, Kirti? Stainless steel. I'm speaking about magnet. Where you are? What about stainless? Yes, Shubha, correct, but I'm not getting any specific answer. I need very specific. Yes, again Priyanka answered correctly. That is, the direction of the field lines is from South Pole to the North Pole. The direction of the field lines is always from South Pole to the North Pole. Very good. Very good. And the magnetic field lines always shows closed or open curves. The magnetic field lines shows closed or open curves. Which is right answer? Yes, it is again Priyanka answered. It is closed curves. Always the magnetic lines are closed. Here and closed, Revati, not at the center. Previously, I posed the question, what happens to the direction of lines at the center? Okay. But when generally speaking, for the magnetic lines, always the lines are showing closed curves. Nandita, Tejashwini, Kirti, Vidya, Shubha, Aishwarya, all of you answered correctly. Good. Good. My next question, because this is so tough, if you feel like your answers are correct, then concept will be retained in your mind. If you don't know the concept is cleared or not, then always it will remain doubts in your mind. Okay, all answering correctly, that your concept is good. Those who went wrong, let them rectify. Okay, my next question is, in a simple electric circuit, when the direction of current is reversed, in a simple circuit, when the direction of the current is reversed, what about the deflection of the needle, magnetic needle? What happens to the deflection of the needle? Okay, so always receive the instruction in the right manner. Okay, that's it. Pose it. Very good, Revati. Now you received the instruction so perfectly, right? Revati, this is tough direction. Priyanka, correct? Yes, Tejashwini, Vidya, everybody answering correctly. So nice of you all. Yes, Manasa, correct. Okay, my next question is, when in an electric circuit, the conductor is connected to a cardboard and iron fillings is sprayed on it. Okay, and when current is allowed to pass, how that iron fillings are arranged? How the iron fillings are arranged? And what happens to the compass? What happens to its concentric circle? Very good answer. And what about compass needle? Correct, Revati. Correct, Tejashwini. Correct, Vidya. Correct, Nandita. So nice, Arpita. Very nice. Very good. Yeah, Shubha. Correct, Shubha. No, Aishwarya. What you typed, you just have a look. Okay. My next question is, when the main quantities of magnetic field is, they have magnitude and direction. Okay, the main quantities of magnetic field is, they have magnitude and direction. When the current is increased, what happens to the magnitude and deflection? When the current is increased, what happens to the magnitude and deflection? Okay, no problem, Aishwarya. It happens. Good, Priyanka. Yes, deflection increases and the speed at particular point also increases, right? Very good, very good. The magnitude at a given point will increase. In the right hand thumb rule, what does thumb indicates? Thumb rule, what does thumb indicate? Yes, so nice, Shubha. Very good answer. Arpita, Kirti, correct answer. The thumb indicates the direction of the current. Very good, Priyanka. Yeah, Vidya, correct answer. Even Aishwarya, again you went wrong. Again spelling, Aishwarya. Okay, with question, what does the thumb indicates in right hand thumb rule. Yes, kid. Right hand section of the good. Okay, Nandita is having problem with audio. Okay. Do you have any other session today at 7? All of you having any other session today at 7? Asking late? Okay, fine. Okay, fine. So that our quiz program will complete, right? Okay. Now, my next question is fine, we'll complete this. Okay. The fingers in a right hand thumb rule, the fingers wrap around what? What does the fingers wrap? The four fingers will wrap what? Okay, the fingers indicate, okay, the fingers indicates the magnetic lines of the magnetic field. My question is, the fingers wrapping what? What does the fingers wrap? The fingers, all the four fingers wrapping one something. What is there in center? What is there in the center? What the fingers are wrapping? Correct answer, Priyanka. The fingers indicates the direction of the magnetic lines. Of course, that is correct. What does the fingers wrap? What is there at the center? Yes, very good, Priyanka. It's conductor, right? The fingers wrapping the conductor. The fingers are wrapping the conductor and the fingers indicates the magnetic lines direction. The direction of the magnetic lines. Okay, this about right hand thumb rule. Okay, my next question is, yes, Aishwarya, now correct answer. Yes, Vidya, very good answer. Around the conductor, very good answer. Good. All of you answering correctly. Nowhere any confusions. Everything coming out perfectly. Okay, but same thing should be retained. So when it will be retained, when you repeat the concepts, when you go through the material, repeat the concepts, everything it will retain. If not, I'm damn sure within few days you will forget the concepts and you have very less days. Okay, so don't waste the time. Go for the repetition. What you learned previously, what we discussed previously, you need repetition. Okay, all of you? Okay, my next question is, which law is applied on the magnetic field due to the current in a circular loop? I'll repeat. Which law is applied when the magnetic field due to the current in a circular loop? Always remember which law is applied, which rule is applied. This question, because this has been repeated in 2 or 3 exams. Okay. My next question, because after Priyanka no one has replied. I don't know what confusion you all having. In the magnetic field due to the current in a circular loop, it is always supports the right hand thumb rule. Yes, Vidya answered correctly. So late? Why so late? Maybe network problem? Yes, Shubha, and your spellings is so perfect. You're not committing any spelling mistake. Very good, Shubha. I'm so proud of you. Very good. Tejashwini, thumb. What is the spelling for thumb? What's the spelling for thumb, Tejashwini? Okay, my next question is, a coil of circular, and this is called as, I repeat, a coil of circular turns of insulated copper wire wrapped in a cylinder is called as. Okay, Tejashwini, now it's right. The class. Okay, so the answer is solenoid. The answer for my question is solenoid. Okay, thanks for visiting and answering very good responses from your side. Thank you so much. See you all soon. Okay, there is online class for you all. Solenoid is the right answer.